Let's talk about the difference of squares. The difference of squares is a very special factoring pattern. What it says is that if you have two bases, A and B, they're both squared, and then you take their difference, we can factor that always into the sum of the bases, A plus B, times the difference of the bases, A minus B. And we can go backwards to check this. So if I multiply the two together, I'll distribute my A, I get A squared, and I distribute A to B, I get negative A times B. Then I'll move on to my plus B times A, so that's positive A times B. I'll write it in the same order as the last one. Positive B times negative B is negative B squared. And what you see in the middle is that these two terms cancel each other out, and all we're left with is that A squared minus B squared. So if you have two perfect squares with the difference, we can factor into the sum and the difference of the bases. So let's look at a few examples. Number one, I already have a very clear difference of squares. M is being squared, N is being squared. So the bases are M and N, and all I need to do to factor is add those bases and subtract those bases. So that is factored form of M squared minus N squared. Number two, you're not told explicitly what the bases are, but we can rewrite this into something squared minus something squared. Well, the x is just going to be x squared. And then 9 I can write as 3 squared. So then this factors into the sum of those bases, x and 3, and the difference of those bases. My last one, same thing. I'm going to rewrite this as the difference of two perfect squares. A squared is just A squared, but 16 as a square is going to be 4 squared. So then I take those bases, A and 4, I add them, and I subtract them to get my two factors. These are pretty straightforward. They're not always like that, so let's look at this next set of examples. Now, in order to use the difference of squares, I have to have the difference of two squares. So it has to fit this pattern. If they don't, we're going to have to use another method to factor. So we're going to look at each term and try and rewrite it this way. A squared is A squared. Now I need one term to the power of 2 that gets me 4 B squared. So that 4 needs to be rewritten as a perfect square, and that would be 2. And the B squared would have a base of B. You could check this, 2B times 2B. I could rearrange 2 times B, which would be 4B squared. So 2B all to the power of 2 gives me 4 times B squared. So that is the base that I want. Now that I can see my two bases, I take them, I add them, and I subtract them to get my two factors. Number 2, I'm going to rewrite my 16 as 4 to the power of 2, and j squared will just have a base of j. My k squared is already a power of 2, so that's just k squared. So now I can see my bases, 4j and k, so I take those bases, I add them to get my first factor, and I subtract them to get my second factor. My last one, again, I need the difference of squares. 25 would be 5 squared, and x squared is just x squared. 1 is also a perfect square, that's 1 squared. So I take these bases, I add them, and I subtract them to get factored form of my polynomial. And that is a little on the difference of squares. Thanks for watching, and I'll see you next time. Bye.